Hi, good people. Welcome back. In this video, we're going to do another example of hypothesis testing. And I'm also going to upload a PDF of this problem unanswered that you can take a look at before watching the video if you want to try it on your own first. So imagine that you're playing cards with your friend and you were dealt a hand of 10 playing cards. And you start to look at your cards. We're just going to start revealing them. You might start to wonder, is this a regular deck of playing cards? All these cards are red, right? Alright, this one's not red, but let's see. Alright, so out of this hand of 10 playing cards, 9 of them were red and only 1 of them was black. So we might start to form a hypothesis that perhaps this is not a regular, normal, fair deck of playing cards. Maybe it's an altered deck of cards that has more red cards in it. That uh, hypothesis that I just talked about is the alternative hypothesis. We arrived at a little bit of a suspicion that this might not be a fair deck of cards. It might have a higher proportion of red cards. So I'm going to let P here stand for the proportion of red cards in a deck. You could also let P be the proportion of black cards in a deck. It doesn't matter. I'm just going to define it this way. P is the proportion of red cards. So our alternative hypothesis is that there might actually be more red cards. We might than normal, and normally there's 50% of them are red cards. The null hypothesis is always the boring situation. In this case, that nothing has changed. This is a normal fair deck of playing cards that has 50% of them that are red. So our null hypothesis is a normal deck of playing cards, and the alternative hypothesis is that this may be a deck of playing cards that has more red than normal. All right. Is that a one-sided or two-sided alternative hypothesis? Well, since we have the suspicion that it might have more red cards and we used a greater than symbol, that is a one-sided test. It's one-sided because our sample of 10 cards led us to believe that the proportion of red cards in the deck might be higher than 50%. So we are testing the plausibility of the sample proportion deviating that much or more on the right side of the mean. Since our sample led us to believe that there might be more red, we're specifically interested in testing that hypothesis that there's more red. We're not testing the red cards deviating on either side of the mean. We're specifically looking on the higher side of the mean. The proportion of red cards in a deck of playing cards can be modeled by a normal model. What are the mean and standard deviation of this model? So we're going to build a normal model for the null hypothesis. So we're going to operate under the assumption that this is a regular normal deck of playing cards, and we're going to build a normal model based on that assumption, and then we're going to test the plausibility of our sample proportion based on a normal deck of playing cards, and we're going to use that to determine if that's highly unlikely enough to reject our null hypothesis. So the mean for the number of red cards in a normal deck of playing cards, 50% of them are red. And the standard deviation, we're going to use this formula up here. We're going to use our null hypothesis as our P there. And in this sample of cards, it was only 10 cards. And what does that equal? Let's see. 0.5 times 0.5 divided by 10. So we get 0.158 roughly. So I'm going to construct a normal model with a mean of 0.5 and a standard deviation of 0.158. Here it is. It has a mean of 0.5, and I counted 0.158 in each direction 3 times. Now, our sample proportion of our original 10 cards that were dealt to us had 9 red cards and only 1 black card. So that is our p hat, and I plotted that here. 90% of the cards were red. I just drew a little line at where I thought 90% was. And since we're interested in testing that alternative hypothesis that there may be more than 10% or more than 50% of the cards are red, I shaded to the right of that p hat, since this is an upper tail hypothesis test. All right, so basically all we have to do now to answer this question, what is the p-value for the test, is find the area of that little pink shaded region. And I'm going to use the normal CDF feature of my calculator to do that. So I'm going to go second, distribution, second option there, normal CDF. I'm going to set my left bound at p hat, which was 90%. I'm going to set my upper bound at infinity because I want to find the area underneath that the tail from 90% to the right infinitely. So I'm just going to put in enough 9s there to pretty much give me infinity. The mean is our 50%, and the standard deviation was that 0.158. So what is the likelihood of obtaining a sample of 90% red cards and a sample size of 10 in a normal deck of cards or more? Let's see how unlikely that is. There's only a 0.567% chance of that happening. So there's less than a 1% chance of that happening. Our p-value is 0.0057 if I round it. P-value is 0.0057, which is significantly lower than the usual benchmark for statistical significance. Usually people will have hypothesis tests, and if the p-value is less than 5%, that's enough to say that the results are statistically significant and you can reject the null hypothesis. In this case, a p-value of less than 1% is significant evidence to reject the null hypothesis. So, is there enough evidence to reject the null? Absolutely yes. Yes, the p-value is 0.0057. Since p is less than 5% or 0.05, there's enough evidence to reject the null hypothesis. If the 10 cards were drawn from a standard deck of 52 playing cards, it would be extremely unlikely. There would be a 0.57% chance of that result happening for 90% or more of the cards to be red. So if there's such a small likelihood of that occurring in a normal deck of cards, it makes sense to assume that this is not a normal deck of cards, and it most likely has more red cards in it. Alright, that's the end of that example. Thank you for watching, and please attend the video meeting at 1:30 on Friday. I hope to see many of you there, and you can ask me questions about the assignment during that time if you like. Bye-bye.